Hi everybody. The expression which we saw in the last video, the square root of x2 minus x1 squared plus y2 minus y1 squared, is a two-dimensional generalization of the one-dimensional expression, the absolute value of x2 minus x1. Okay, so what do I mean by all of that? Well, over here you can see I have a number line, which is like having an x-axis but not a y-axis. So I have just one dimension here. I have horizontal distances, but I do not have vertical distances. So unlike the last video where I had a coordinate plane with an x-axis and a y-axis, so any point I could put a point anywhere around here. This time I only have one dimension, and it's horizontal in this case. Now, if I asked you, or you asked me, to find the distance between 2 points when we're only given one dimension, then hopefully you learned previously, the only thing that you have to do is subtract the coordinates of those points. That's it. If I want to find the distance between this dot and this dot, then all I would have to do is subtract these two numbers over here and then take the absolute value, just to make sure that I'm writing my answer as a positive number instead of a negative number, because we always write distances as positive numbers. Okay, so for example, we can just by counting see that the distance between here and here is 5 units. So if I start here, I can just count. Let me make this a little bit thicker. 1, 2, 3, 4, 5. Okay, but if I just wanted to use this very simple expression over here, then what I could do is I could call this x1 and I could call this x2, and then I would simply have the absolute value of 2 minus negative 3. So minus negative becomes plus, right? So this is like 2 plus 3, which is 5. So I have the absolute value of 5, and the absolute value of 5 is just 5. And by the way, it really doesn't matter which one I call x2 and which one I call x1, because I have these absolute value symbols here. So I could have called this x2 and this x1, and then if I do the exact same thing, the absolute value of x2 minus x1, now I have negative 3 minus, and then x1 is now 2. So negative 3 minus 2 is negative 5. So now I have the absolute value of negative 5, and the absolute value of negative 5 is also just 5. So it doesn't matter which one I call x1 and x2 if I'm using this expression, because of these absolute values symbols here, which in the end just make sure that my answer is negative. Okay, now in this video I'm showing you that this expression which we have over here is really just a generalization of this expression to 2 dimensions. So we already saw in the last video that this expression works in 2 dimensions, but it also works in 1 dimension. So first of all, a generalization means, this being a generalization of this means that I can use this in place of this. So if I have just 1 dimension, I can use this instead of this, and it will still work, but I can also use this for 2 dimensions. So it doesn't mean that this is only for 2 dimensions and I have to use this one if I'm doing 1 dimension. This being a generalization of this means that this one works for both. So we already saw in the last video that it does work when we have 2 dimensions, when we have an x-axis and a y-axis. I'm going to show you in this video that this also works when we have just 1 dimension. So I want to use this expression now to get that same answer that I just got before. And the way to do that is to realize that since we don't have a vertical axis over here, then we can think of the y values for both of these points just being 0. Okay, so this point I can call, let me do it now in blue. I can imagine that this, where's 0? Here's 0 over here. So I can imagine that this is simply the x-axis of a two-dimensional coordinate plane, and the two dots just happen to be both on the x-axis, with neither one of the dots going off of the x-axis. Okay, so that would make this point -3, 0, and that would make this point 2, 0. Okay, and by the way, you could also think of it as both of these points. Well, you know what? Let me save that until later in the video. Okay, remind me to talk about another way of thinking about it. But anyway, if I do think of these y values as simply being 0 and these two dots simply being along the x-axis here, then if I were to use this expression, so we have the square root of x2 minus x1 squared plus y2 minus y1 squared, which is equal to, let me just plug everything in now, the square root of, so my x2 is 2, and then my x1 is negative. Remember, so this is x1, this would be y1, this would be x2, and this would be y2. Okay, so 2 minus x1, which is -3 squared, plus, then y2 and y1 are both 0. So this is just 0 minus 0 squared, okay? So now this whole thing is equal to the square root of, so 2 minus -3 is 5, so 5 squared, and then plus, well, 0 minus 0 is just 0, and then 0 squared, which means 0 times 0 is still 0. So I could put plus 0 over here, but you don't even need to write plus 0. Okay, so you just have this over here. So you can see that this is looking very similar to what we had over here, where I have this 2 minus -3, and here I also had 2 minus -3, and I didn't have anything else over here, but really I don't have anything else over here either, because both of these are just zeros. Okay, so then I just have to do, I don't know why I made this so long. Let me shorten that. Then I just have to do 5 to the second power, which is 25, and then the square root of 25 is just 5. Okay, so we get the same answer just like we got before. And if we had done it, if we had called this one x1 and y1 and this one x2 and y2, then we would have gotten the same answer of 5, okay? So what was I saying before? We could have imagined that instead of this axis over here, instead of this number line being the x-axis, we could have imagined that, let's say this is, you know what, let me just to make it simpler. We could have imagined that this is the x-axis, and I don't know, let's say that these points both have a y value of, let's say, oh, that's bad. Let's say that both of these points have a y value of 4. Again, it really wouldn't make a difference, because then when we just plug in y2 minus y1, then we would get 4 minus 4, which again is just 0, and then 0 to the second power is still 0. So again, the only thing that would matter, since these are both along the same horizontal line, the only thing that would matter are the x values of these dots over here. Okay, so that's it. So now we can see how this is just like a generalization of this, with both of these y values either both being 0 or just both being the same number and canceling each other out. Okay, All right, so that's it, and have a great day.